So a player kicks a football from ground level, so we know that the height will be basically 0, with the initial velocity of 27 meters per second. So they tell you the initial velocity is going to be 27 meters per second, 30 degrees above the horizontal. So it means that if I have my ground level here, the angle 30 degrees will be right here then, and the ball will be launched like this. And so let's go ahead and put as my givens. So initial velocity is 27 meters per second. My angle is 30 degrees. So let's go ahead and look at my unknowns. For part A, is asking me the ball's hang time. So time, I now know that's what I have to find. So time is unknown. For part B, ball's maximum height. So I'm looking for displacement in the y direction then. Part C, the horizontal distance. Right here. Horizontal distance the ball travels before hitting the ground. So this is referring to my displacement in the x direction. Before we move on to solve the problem, we have to find the initial velocity in the x direction and the initial velocity in the y direction then. So I'll go ahead and do that next. So on the previous slide, I learned that the initial velocity is 27 meters per second. I know that the angle involved is 30 degrees. So if I were to draw my velocity vector, it will look like this. And this is the ground level. This angle here would be 30 degrees. And this is the initial velocity. And the initial velocity is 27 meters per second then. Okay, but in projectile motion, we can't use this 27 meters per second because of this angle. We can only analyze its x and y components. So what do I mean by that? Let's go ahead and draw this as a right triangle. This is going to be my 90 degrees. This right here is my hypotenuse, and the length of this hypotenuse is 27 meters per second. And this is, again, 30 degrees. So projectile motion, we can't analyze using the hypotenuse. Instead, we have to analyze the problem using the length of this side, which I'll let be x, the length of this side, which I'll let be y, and then these two values, once I find them, I can use them to solve for my answer. So right now, how do I solve for my x and y? Well, I have to use my trig properties. So you should remember the 3 trig properties. Cosine of theta is equal to adjacent over hypotenuse. Sine theta is equal to opposite over hypotenuse. And finally, tangent of theta is equal to opposite over adjacent then. In order to solve for my x and y, I had to use one of these trig properties for each one. So let's look at x then. To use these trig properties, I have to first label my right triangle then. So, for example, I already know my hypotenuse is this one right here. This is my hypotenuse. Right? So I have to figure out which one's adjacent, which one's opposite. Well, if my angle's right here, and then this side right here that's touching the angle, this is known as my adjacent side. And because this side, where the y is not touching the angle, this is known as my opposite side. So now, to solve for x, looks like I have my adjacent and my hypotenuse, so I'm going to use cosine then. So I'm going to rewrite this as cosine of, I'm going to plug in my angle of 30 degrees is equal to adjacent, which is my x, over hypotenuse, which is going to be 27. Go ahead and solve for x. I'm going to multiply both sides by 27. I will cross this out. So now I have 27 times cosine of 30 degrees equals to x. And for my y, or the opposite side, Looks like I have opposite and I have hypotenuse, so I could use sine then. So in this case, I'm going to have sine of 30 degrees is equal to opposite, which is y, over hypotenuse, which is 27. Go ahead and solve for y by multiplying both sides by 27. This 27 cross out. I'm left with 27 times sine of 30 equal to y. Oh, this should be cosine. Now make sure you're in degree mode before you punch in the cosine 30 and the sine 30. If not, you're going to get a different value, and then from there your answer will be wrong then. So if I punch in 27 times cosine of 30 into the calculator, I should get 23.383 then, and that's my x. If I punch in 27 times sine of 30, I should get 13.5 is equal to y. So what I've basically done is that instead of using the 27 meters per second, I found the initial velocity in the x direction, which is 23.383 meters per second. And this is my initial velocity in the x direction. And I found my initial velocity in the y direction, so I'm going to rewrite this as 13.5 meters per second is equal to initial velocity in the y direction then. So now I have my new givens now. So from our previous slide, we know that the initial velocity in x is 23.383 meters per second. The initial velocity in y is 13.5 meters per second. You may notice that I don't have the initial velocity 27 meters per second, nor the angle 30 degrees listed as my givens anymore, because these two values, their only purpose was to get this and this. Once I found these two values, I will no longer need this and this. So now I can move on with the problem. Now once we found out the initial velocity in x direction, we automatically know the final velocity in x direction will be the same as this value right here. So the final velocity in x then will also be 23.383 meters per second. Two givens that are not stated in the problem are the acceleration in the x direction and the acceleration in y direction. The acceleration x is going to be 0 meters per second square, and the acceleration in y is always going to be negative 9.8 meters per second square then. And finally, another given deals with the football. The football leaves the ground level and lands back on the ground level. So that means that the y displacement in this case is going to be 0 meters then. So now we have to figure out of our 8 equations which one to use. Now let's go ahead and look at the x direction first. First, we already know that all the kinematic equations have the initial velocity in the x direction. So it has it here, it has it here, here, and here. So this does not eliminate any equations from our list. Next, final velocity. I have final velocity here, final velocity here. This equation does not have final velocity, so I could cross this one out. This equation has final velocity right here. Next, I need acceleration. This equation does not have acceleration. This equation has acceleration. This equation has acceleration. And finally, I need time. So time is listed right here. Time is not listed here, so this equation is crossed out. However, this equation will not give me my answer because the final velocity is equal to initial velocity. If you do the mathematics for this, it turns out that you're going to get 0 is equal to acceleration times x times time. And if this is 0, that means I won't be able to figure out what time is. So this equation is actually crossed out too. So we'll go ahead and move in the y direction then. So first, all the equations have the initial velocity in y. Next, I need the acceleration in y. So let's go ahead and underline those. This equation does not have it. This equation has it. This equation has it. This equation has it. Next, y displacement. This equation does not have y displacement. This equation has y displacement. And this equation does not have y displacement. And finally, I need time. And time is listed right here and here. So it looks like I'll be using the third equation in the y direction to solve for my time then. So from the previous slide, I know that the equation I need is y displacement is equal to initial velocity in y times time plus 1/2 acceleration in the y direction times time squared. Now to simplify my math, I'm going to use one of my givens. Y displacement is equal to 0 meters then. So I'm going to go ahead and plug in the 0 here. So I get 0 is equal to initial velocity in the y direction times time plus 1/2 acceleration y times time squared. To get time by itself, I'm actually going to move one of the terms over. So I'm going to move this term to my left hand side. So I'm going to subtract initial velocity in y times time. I'm going to minus initial velocity in y times time. So that now this term and this term will cancel. So I'm going to get negative initial velocity in y times time is equal to 1/2 acceleration y times time squared. Now from here, I have a time and a time squared. What I can do is divide both sides by time. And what this will do is I'm going to cross out this time. And I have a time squared over time. This time will cross, and I'll be left with just one time. So now I have negative initial velocity in y is equal to 1/2 acceleration y times time now. Now I have to isolate this time. I'll go ahead and multiply both sides by 2. So I'll get rid of this 1/2 right here. So 1/2 and 2 cross out when they multiply. On the left hand side, I'll be left with negative 2 times initial velocity in y is equal to acceleration y times time then. So now I have acceleration in the y direction times time. So to get rid of this acceleration, I'm going to divide both sides by acceleration y. So these two terms will cross out. I'm going to continue on this right hand side. I'll be left with negative 2 times initial velocity in y all over acceleration y is equal to time now. So I'll go ahead and rewrite my equation again. Negative 2 times initial velocity in y all over acceleration in the y direction equal to time. Now I'll go ahead and plug in my values into here. So I'm going to rewrite negative 2. My initial velocity was 13.5 meters per second. And the acceleration in the y direction is negative 9.8 then. So notice that a negative divided by negative, it'll cancel out. I'm going to get a positive number. So I'm going to hit positive. I'm going to multiply 2 times 13.5. That should give me 27. So 27 divided by 9.8. If I divide those two numbers, I should get a positive 2.755. And that is equal to my time. And my units for time, remember, is seconds. So I'm going to get plus 2.755 seconds then is equal to my time. Now we'll double check our answer to make sure it's correct. So we found the time to be 2.755 seconds. The first thing you want to check is the answer positive? Because we can't have negative time. And our answer is positive, so that's good. Second, you want to check to see is it too small, too big, and does it seem reasonable for the object in motion. So we have a football traveling in the air. It does seem plausible that it can travel for 2.755 seconds in the air. It's not too small, nor is it too big, so it seems like our answer is correct then. So for part B, I'm asked to find the height, or in other words, the y displacement of the football when it reaches the maximum height. So I'm going to use the same givens as before, but there's one more given that is not listed here. Well, I'll go ahead and show you how we get that given. But first I'm going to draw the path of the football. So we now know it's going to be a parabolic path. And so before I begin, I'm going to change the color of the pen. Okay, I'm going to draw the motion diagram for the velocity vector in the y direction. So basically, I'm going to draw the velocity vectors at each point. I'm going to do it here. And at this point, it's somewhat decreasing speed. All right, at this point, it gets smaller. At this point, it doesn't have it. And at this point, it's going back down. So it's going back down. And finally, at this point, it's basically like this then. So in this problem right here, and okay, change it back. Notice that the velocity in the y direction, it has maximum value here. That's its initial launch. But then as the football is going up towards maximum height, these vectors decrease until here. You might notice there's just a red dot. This means that the velocity in the y direction here is actually 0. So that means that the final velocity when the football reaches its maximum height, it's going to be 0 meters per second then. And then once from here, it starts going back down, it starts to increase its speed in the downward direction then. So now, with all my givens, I could go ahead and figure out which equation I'm going to use. Now, since I'm going to find the y displacement, I'm going to not need the x direction at all, so I'll cross that out. So that means that for these kinematic equations, I'll go ahead and cross them out. And now I'm going to go ahead down the list. So first I need initial velocity in y. All 4 kinematic equations have that value, have that variable. Next, I need the acceleration in y. So this equation does not have it, so I'll cross that one out. This equation has it, this equation has it, and this equation has it. Next, I need final velocity in y. This equation has it. This equation doesn't have it, so I'll cross it out. And this equation has it right here. And finally, I need displacement. This equation does not have displacement. I'll cross it out. Displacement is right here. So it looks like I'm going to be using the 4th equation to get my unknown, the y displacement then. Okay, now I'm going to go ahead and rewrite my equation. So I now know I need the final velocity in y squared is equal to initial velocity in y squared plus 2 times the acceleration y times the y displacement, or I'm going to just write y. So to help simplify my equation, I'm going to plug in the final velocity is 0 because that's basically one of the givens I found out. So if I plug 0 to here, I'm going to get 0 is equal to initial velocity in y squared plus 2 times the acceleration in y times y displacement. I'm going ahead and subtract the initial velocity squared. Going to subtract both sides now. This will cancel out. And so on the left-hand side, I got 0 minus initial velocity in y squared. So I'm going to get negative initial velocity in the y direction squared is equal to 2 times acceleration y times y displacement then. So I'm trying to solve for y. So what I can do is now divide both sides by 2 times the acceleration y. Divide 2 by acceleration y. This cancels, this cancels. So I'm going to be left with negative initial velocity in y squared all over 2 times acceleration y, and this will be equal to my y then. So now I'm ready for the next step. Now I'll go ahead and rewrite my equation again. Negative initial velocity in y direction squared all over 2 times acceleration equals to y. I'm going ahead and plug in my values then. So I'm going to get negative. My initial velocity in the y direction is 13.5 squared all over 2 times acceleration, which is negative 9.8. I'll go ahead and multiply the bottom. And I'm going to go ahead and square the 13.5. So I'm going to get 182.25 at the top. And at the bottom, I'm going to get a negative 19.6 then. Notice that I'm going to have a negative divided by a negative, so it means I'm going to get a positive number, and 182.25 divided by 19.6, that actually gives me 9.298. And because I'm dealing with the y displacement, I know my units for the y displacement has to be in meters then. So my answer for part B is 9.298 meters equals to the y displacement. Now we need to double check our answer just to make sure it makes sense. We found the y displacement to be 9.298 meters then. Now, we have to see is it positive or negative. In our case, it's positive, which makes sense because it means that it's above the ground level. Next, we have to see is it too small or too big. So it's not too small. It's not 0.01. It's not too big, like 100 meters. And we have to see, does this answer seem plausible? Well, 9.298 meters, that's actually equal to about 30 feet. So the football does seem like it can travel 30 feet into air. So our answer does seem plausible then. So for part C, we need to find the total horizontal displacement of the football traveling in the air. So that means that I need an equation with the x displacement then. So that means that the equation in the y direction, because they have the y displacement, I'm not going to use any of these bottom four equations. So I'll go ahead and cross these out. And because I'm not using equations in the y direction, I could cross out the givens in the y direction. So I won't need any of these. And now I have to double check which equation in the x direction I would use. So this one has displacement. I can't use that one. This one has displacement. I could use that one. This one has displacement. This equation does not have it, so I'll go ahead and cross this one out. Next thing I want to check to see which equation has time. This equation does not have time. This equation has time. And this equation has time. Now from this point, you actually have two equations you can use. The reason is because you have acceleration, which is here. You have initial velocity, which is here. And this one has initial velocity. You also have final velocity, which is here. So you have two equations you can use to solve for the x displacement. Either this one or this one, because you have all the given information to use both equations then. So for this problem, I'll go ahead and use the third equation to solve for the total x displacement then. Now I'm going to go ahead from the previous slide, I'm going to rewrite my equation. So x displacement is equal to initial velocity in x direction times time plus 1/2 times acceleration x times time squared. The reason I like to use this equation is because the acceleration in the x direction is going to be 0 meters per second squared. That means if I plug 0 into here, this whole term will drop out then. So I won't even have to worry about this. So if I plug in 0, I'm going to end up with total displacement is equal to initial velocity in x direction times time. And because the unknown, the x displacement, is already isolated and by itself, I don't need to rearrange the equation then. So I'll go ahead and go to the next step. So using my equation, the total displacement is equal to initial velocity in x direction times time. I'll go ahead and plug in my velocity in the x direction, which is going to be 23.383 times it by time, and it is 2.755. Multiply those two numbers, I'm going to get 64.420. And because I'm dealing with total displacement, the unit for total displacement is going to be meters then. So my answer should be 64.420 meters. Double checking my answer. You want to make sure that the sign is correct. The number is not too big, it's not too large. So looking at it, it looks like I have a positive number, which makes sense. The football is traveling to the right, and right is usually considered to be positive. It's not too small. It's not like 1 meter, half of a meter. And it's not big like 1,000 meters, 2,000 meters, or 1,000,000 meters in the case of a football traveling. So it looks like this answer makes sense then, and we're done with the problem.